Ever think about how exactly drugs manage to fight off bacteria? Well, today we're going to zoom in on one of the big players, historically speaking at least, sulfonamides. You might know them as sulfa drugs.
Yeah, those guys.
So we're going to do a deep dive and look at, how they actually work, what they're used to treat, and why they still matter, even today.
Right, because they are still around.
They are. And we've got some really interesting information here about their structure,
Okay.
how they move through the body, and even how bacteria try to, get around them.
Oh, clever bacteria.
So our mission today is to really break down the essentials of sulfonamides and sort of point out those light bulb moments in this area of drug discovery.
Yeah.
It's fascinating stuff.
Yeah, absolutely. It's a real cornerstone of medicinal chemistry, I think.
So maybe we should start with what actually are sulfonamides?
Sure. So at their core, all sulfonamides share a specific structure. It's called a sulfonamide group, which is basically a sulfur atom with two oxygen atoms and a nitrogen with a hydrogen on it.
Okay.
And that group is attached to a benzene ring,
Benzene ring.
which is 6 carbon atoms arranged in a ring.
Okay.
And on that benzene ring, you'll also have an amino group. So that's a nitrogen with 2 hydrogens.
Got it.
And the simplest form of this, the sort of prototype, is sulfonilamide,
Okay.
where you don't have anything else attached to that benzene ring.
Interesting.
Yeah.
So what's so special about this structure? What makes it work?
Well, the key is that this particular structure allows sulfonamides to interfere with a crucial process that bacteria need to survive.
Okay.
You see, bacteria, unlike us, need to make their own folate, that's vitamin B9.
Okay.
And they need that folate to synthesize nucleic acids and proteins.
Right.
Essential for growth, right?
Makes sense.
Now, to make folate, bacteria use a molecule called para-aminobenzoic acid.
Right.
And an enzyme called dihydroxyapatite synthase.
We'll just DHPS.
DHPS, yeah, much easier.
Yeah.
So this DHPS is like the folate making machine, so to speak.
I like that. Folate making machine.
Yeah.
Okay. So how do the sulfonamides fit into this whole picture?
So this is where it gets really interesting. Sulfonamides, they're kind of like molecular imposters.
Okay.
Their structure closely resembles PABA.
Oh, I see.
So when the bacteria are trying to grab PABA to feed it to their folate-making machine,
Right.
the sulfonamide steps in and blocks the process.
Sneaky.
Yeah, it basically jams up the works.
So then the bacteria can't make folate,
Exactly.
can't build their essential components,
Yep.
and then they can't grow.
Their growth stalls. Exactly.
Yeah.
And that's how sulfonamides work.
That's really clever. And what I find really interesting is that humans, we don't make our own folate. We get it from our diet.
That's right. That's the beauty of it.
Mhm.
So sulfonamides, they primarily target bacteria without harming our own cells.
That is so cool. So it's
Yeah.
like they make what we eat so we don't have to worry about it.
Precisely.
That's awesome.
Yeah.
So against which infections are these? Are these drugs actually effective?
So sulfonamides, they're used for a variety of bacterial infections, especially urinary tract infections, UTIs.
UTIs,
You've
yeah.
probably heard of those.
Right.
They're also effective against some respiratory infections like pneumonia
Okay.
and even some gastrointestinal infections.
Sure.
And then there are some less common infections caused by organisms like nocardia and actinomyces, which sulfonamides can handle pretty well.
Okay.
And even, believe it or not, some protozoan infections.
Wow.
So quite a range.
So versatile. Sometimes doctors prescribe a combination of drugs
Yes.
to make them more effective. Does that happen with these?
Absolutely. A classic example is combining sulfonamides with a drug called trimethoprim.
Okay.
So trimethoprim, it also interferes with folate synthesis, but it blocks a different step in the pathway.
Oh,
So
interesting.
you're basically hitting the bacteria with a double whammy.
Got it.
And this combination is often more potent than using either drug alone.
It's like a 1-2 punch.
Exactly. And it's worth noting that sulfonamides are also used quite extensively in veterinary medicine.
Oh, interesting.
Yeah.
To treat infections in animals.
Mhm.
Okay, so they're good at blocking
Yeah.
bacteria.
Mm-hmm.
But we know that bacteria are pretty adaptable, right?
Yes.
So why do these drugs sometimes fail? How do the bacteria get around them?
That's the big challenge, right? Antibiotic resistance.
Right.
Bacteria are constantly evolving. And over time, they've figured out ways to outsmart sulfonamides.
Of course they have.
One common way is by changing their DHPS enzyme, their folate-making machine, so the sulfonamide no longer binds effectively.
So it's like they change the shape of the lock so the key no longer fits.
Exactly. Another tactic is to just produce a ton more PEBA. So they're basically overwhelming the imposter drug with the real deal.
Clever.
Yeah. And then they can also acquire new genes that code for different folate enzymes, ones that sulfonamides can't touch.
So they just like change the whole system.
Exactly. Or even find alternative ways to grow without relying on the pathway that's being blocked.
Wow.
So it's really a constant arms race.
Yeah.
We develop new drugs, bacteria develop resistance.
It's a battle. So what happens to these drugs when we take them? Like, how do they move through the body?
Ah, that's pharmacokinetics.
Okay.
So sulfonamides are generally absorbed quite well when taken orally.
Okay.
They then get distributed throughout the body, metabolized in the liver,
Okay.
and then primarily excreted by the kidneys.
Okay. Makes sense. Are there any downsides to using them? Any potential side effects we should know about?
Yeah, like all medications, sulfonamides can have some adverse effects.
Okay.
Some people may experience hypersensitivity reactions, which can range from skin rashes to more serious conditions. Okay. There can also be effects on blood cells, like a decrease in white blood cells or platelets.
And what about the kidneys? You mentioned those earlier.
Right. So kidney problems are also possible. In particular, there's a risk of crystalluria, which is when the drug crystallizes in the urine.
Ouch.
Yeah, not fun. So staying well hydrated is really important when taking these drugs.
Really important.
And then, of course, there's always the possibility of gastrointestinal disturbances, nausea, vomiting, diarrhea.
Usual suspects.
Exactly.
Okay, so to kind of recap here, sulfonamides,
Mm-hmm.
really clever drugs.
They are.
They exploit this key difference in how bacteria in humans get an essential nutrient.
Yeah.
They basically mimic a building block
Right.
and jam a bacterial enzyme.
Precisely.
It's like sabotage at the molecular level.
It is, yeah. It's a really elegant mechanism.
And they've been hugely important historically,
Oh, absolutely.
in treating bacterial infections. And they still have a role to play today, often in combination therapies.
That's right.
However, this whole issue of resistance,
Mm-hmm.
it really underscores just how adaptable bacteria are.
They are incredibly adaptable.
And makes you think, like, how do we stay ahead of them?
That's the million-dollar question, isn't it?
And all of this, it really makes you consider, given how quickly bacteria can evolve resistance,
Mm-hmm.
what does this tell us about our efforts to develop and use antibiotics effectively?
It's a constant challenge.
It is.
And I think it emphasizes the need for new approaches.
Yeah.
For being really careful about how we use antibiotics.
Absolutely.
To avoid fueling this resistance problem.
It really makes you think about that balance between the benefits and the potential harms of these antimicrobial therapies.
Sure.
Well, lots to ponder there.
Yes.
Fascinating stuff.
It is, yeah.
Thanks for joining us on this deep dive.
My pleasure.